Good morning, class. Welcome to today's lesson. Today we will be looking specifically at building construction, materials, characteristics, and uses. And we will conclude today's lesson with looking at how some of these issues can affect human health and safety. So we begin by looking, first of all, at a definition of building materials. So we define building materials as any material used for construction purpose, such as materials for house building. Examples of some of the most common materials that would be used would be things like wood, cement, aggregates, which would be, a combination or aggregation of different sizes of materials, metals, bricks, concrete, clay, etc. And of course, the choice of these materials would often be based upon um, the cost of the material and usually also the purpose of the material for the building project. All right. And, from a public health perspective, you also have to consider the public health implications of the particular material types as well. So many naturally occurring substances such as clay, sand, wood, rocks, and even twigs and leaves have traditionally been used as part of the construction of buildings. So we have natural type materials where very little or no processing has been done to them. Apart from that, we also have naturally occurring materials, um, apart from the naturally occurring materials, we have many man-made products, which would be more or less synthetic in nature. So we might be talking about things like plastics or combination of plastics or alloys of different metals, etc. So the manufacture of building materials is an established industry in many parts of the world. It's huge. This is like the construction sector, for example. We have major manufacturing industries that develop in order to facilitate the construction sector. And some of these um, types of industries may be specialized in nature. For example, we're talking about industries that would produce supplies for carpentry, plumbing, roofing, or even insulation work, which typically insulation work would be most needed in temperate and cold regions. We don't often need it to such an extent in tropical regions. So I hope you can see the slide. It should be legible, though the font is a little bit on the small side. So here we're going to start looking at some different categories of building materials. So for example, we have the natural construction materials that would include things like, as I said, these would be unprocessed or minimally processed materials such as lumber from wood or glass. Then we have mud, stone, and fibrous plants that used to make basic materials. And there are many parts of the world actually that still use a lot of these types of materials in the construction of their homes. Um, these types of materials, these natural materials, tend to do a very good job of regulating temperatures, keeping the homes warm during the day, cool during the night. I beg your pardon, warm at night and cool during the day, my mistake. Um, then we have materials that are fabric in nature. So for example, we have tents that used to be the home of choice for a lot of nomadic peoples across the world. So we go back in history a little bit. Um, some typical examples that you might be aware of, we have the conical teepees. Those are the ones that look like the cones. Then we also have the circular yurts, which are also tents, but they're circular tents. All right, not domes, but a circular tent. You all may have seen some of these as well. Now, it has been revived, the use of fabric revived as a major construction technique with the development of tensile architecture and synthetic fabrics. So, for example, with regards to the synthetic fabrics, um, we see an actual industry out there. For example, in Trinidad and Tobago, we see a lot of these synthetic tents being provided, all kinds of styles and sizes for various types of events, both large and small out there. Then we also have mud and clay. So the amount of each material that is used leads to different styles of building. Um, the deciding factor is usually connected with the quality of the soil being used. So the type of the soils vary from location to location. So you have to be aware that, of course, the way in which the materials will behave will be different according to the type of the soil, um, and of course, the utility or usefulness in creating your homes. So, as mentioned before, homes built with wood tend to naturally cool in the summer heat or daytime heat, and it's warmer in the cold weather or nighttime, right? So clays, for example, they tend to hold heat or cold, releasing it over a period of time. Then we also have rock. So rock would be one of the longest lasting building materials, very long lasting, they're very strong, and readily available in many parts of the world. But one of the major disadvantages of the rock is the actual weight of the stone and the ability to transport it. So that is what makes it very difficult. For example, we know that granite is actually a much sought after building material because of its strength, durability, etc. Then we have thatch type materials, one of the oldest of materials known. This involves the use of like grass, for example. So grass is a good insulator from heat and cold as well, and it is easily available and easily harvested. So we find that we have many native tribes across the world that actually still live in homes that are made completely of grass year round. Then there's brush, similar use to that of thatch, but the brush is actually made up of different plant parts, leaves, branches, etc. And this type of building material would often be found in tropical and subtropical areas such as rainforests, where the leaves and branches will be made to construct the building. Then there is ice, another maybe unusual one. For example, you would have heard about the use of ice to make igloos in the Inuit communities in the polar regions. Also, you may have heard of the use of ice to develop and construct ice hotels as tourist attraction in northern areas that might not normally have a lot of winter tourists, but it's used as a tourist attraction. And then, of course, we come to the more familiar types of materials now, like wood. Um, so wood we know is a product of trees and sometimes other fibrous plants, and they are used for construction purposes when cut and or compressed into lumber or timber to make boards, planks, and other materials that we would be more familiar with. Okay, this is a generic type of building material and is used in just about any type of structure in any climate type. Okay, then we have the bricks and the blocks. So the brick is a block made of clay or shale, but it's also made of lower quality mud. So you can make bricks from different types of material. So for example, here in Trinidad, one of the bricks that we would be familiar with, brick types, would be that reddish brown clay brick. All right. Bricks were widely used as a construction material in the 17, 18, and 1900s as they were more flammable, less flammable, sorry, more flame retardant than the wood in ever crowded cities, and also fairly cheap to produce. So I'm sure you could imagine that once they discovered a building material that would have been less dangerous in terms of promoting fires in those crowded cities, they would have gravitated more towards the brick And in modern times now, we find that we now have cinder blocks or those concrete blocks that are now available. So you see a lot of um, buildings around us now going up and being constructed using the concrete blocks, okay, which would be usually more resistant, harder, also heavier, um, but it's also now an option for us in terms of building. Of course, we also still have the use of much of the clay blocks available to us out there. So concrete. Concrete is a composite building material made from a combination of aggregates or composites and a binder such as cement. All right. So the cement is the binder, and all those aggregates of different sizes of types of materials, stone, sediment, etc. The cement will bind it to make what we know as concrete. Now, since concrete has a rather low tensile strength, meaning resistant under pressure to breaking, um, it is generally strengthened using the steel rods or the bars or wire shootings. I'm sure maybe many of you may have seen this before. So that is usually, if you're doing casting or anything like that, they would usually include that and cover it over to increase the strength of the concrete. Additionally, concrete has been a predominant material in this modern age due to its longevity, formability, meaning that you know, you can shape it into any shape or any type of environment, etc. And it's also easy to transport. Then we also have metals that are used as construction framework for larger buildings, such as skyscrapers, or as an external surface covering. So, for example, it can, as I said, it could be used in many ways. So, for example, when you see larger buildings going up, you would see on the outside of these buildings, they put up these framework um, to facilitate the actual process of construction. But metals can also be used in a variety of other ways. So types of metals that would be used in some of these larger buildings would be steel, aluminum, titanium is very strong. Then we have chrome, gold and silver. The gold and silver and chrome, etc., could be used for decorative purposes because they're very expensive. All right, the steel and the titanium would be used for structural purposes. So to increase the strength and durability of the larger building structure. Then we also have glass, another type of material that's commonly used in building construction. Glass would be used to make windows. So the glass is generally made from a mixture of sand and silica, and it's very brittle. We also find that a lot of modern buildings will actually have entire glass walls. Okay. All right, and it's um, used to span over a wide roof structure in a space frame. All right, so for example, you might be looking at things like sunroof, things like that. Then we have ceramics. Ceramics, how are ceramics used? They're mostly used as fixtures or coverings in buildings. For example, on walls, countertops, ceilings. You can have ceramic tiles, etc. All right, different types of fixtures. We have plastics. Plastics cover a range of synthetic and semi-synthetic products that can be molded or shaped into different types of objects in the building, different fixtures, etc. And these are used because they vary immensely in heat tolerance, hardness, and resilience. So they're quite versatile in terms of use, the plastic. We also have examples of foam material being used. These are lightweight, easily shaped, and an excellent insulator. Now, typically in more temperate and cool type countries, you find that the foam would be used as an insulator as it is sandwiched between cement or concrete outer walls and the wooden inner walls to provide insulation against heat and cold. Then we have cement composites. Um, so these are products made of hydrated cement paste that binds wood or other types of particles or fibers to make precast building components. For example, you might be familiar with prefabricated cement walls or concrete walls. All right. So you're not building brick by brick. You actually have these prefabricated walls that can be used. And usually once these are available, you can put up a building structure very quickly. Then we also have what we classify as virtual building materials. Um, that's, for example, that would be used in the latter stages of your building. Once it's already constructed, you start putting fixtures together, photographs, images, text. Maybe a text might, for example, be, if it's a commercial building, a sign of various nature, right? So we refer to these as virtual. Then we have other building products. So we have ready-made particles that are fitted in different architectural, hardware, and decorative parts of the building. These might include, the windows, the doors. These would have been fabricated elsewhere, so you would bring these in and fit them into your building. Okay, so now we're going to look briefly at, so we've looked at types of materials. Now we're going to look briefly at some of the various significant components of a building. So we're going to look at foundations and retaining walls. So the foundation of a building transfers the weight of the building to the ground. So the weight of the building would be referring to the weight of things like your walls and your roofing, etc. So since the weight of the building rests on the soil or the rock, depending on the nature of the location or the geology of the location that you're at, the engineers have to study the properties of the soil very carefully to ensure that it can carry the weight of the soil, the weight of the load imposed on the building. So that is very important because you can have actually create long-term problems in terms of the not only the durability of the building, but you can cause harm to humans and human beings and occupants of the building if the soil is not properly studied and that you have not been able to determine that the soil is what we would consider strong. All right. Typically, you would find that rocky soils would be stronger. Something like if you have clay soils or sandy soils, those would be considered weaker soils because you have issues of the integrity and the stability of the soil there because clay can be easily waterlogged. Um, sand is weak. It's very airy. All right. So what do we do? What are some of the things that we may do to try to strengthen a building? We would look at the foundations that need to be used. For example, we have two types of foundations. We have shallow foundations and deep foundations. Um, so we have the shallow foundations. These are also called spread footings or open footings, and these transfer the building loads to the earth that is very near to the surface rather than a subsurface layer. So if I flip to the next slide, you will see this is an example of a shallow foundation here. This is the deep foundation where you could clearly see if this here is your ground layer, the deeper foundation goes much deeper than that of the shallow foundation. And typically it would give more strength. Notice you have a lateral structure here attached to the vertical wall. This tends to provide some stability, right? Now, if we go back to our description here, the deep foundation, we see that associated with the deep foundation, we don't see it on the diagram, but you can also include a pile or a piling that is a vertical structural element of the deep foundation that's driven or drilled deep into the ground at the building site. So for example, additional piles or pilings can be added here. For example, from here, from this base of the foundation here, it can actually have other structures driven further deeper into the soil to add stability to your foundation. Then we have retaining walls. So what is the purpose of the retaining wall? They are used to support soil laterally so that it can be retained at different levels on the two sides. So what do we mean by that? In other words, prevent the soil from moving across the land surface from one location to the next. All right? So a retaining wall that retains soil on the back side of the wall, that's usually the side that you want to keep it on. And then you have water on the front side. It's called a seawall or a bulkhead. All right, so you just give it a different name. It's a retaining wall. Here we have some examples of retaining walls. What I will do is I will flip back and forth from this slide and the next, because the next slide actually gives us a text description of each. So we have a gravity wall, piling wall, cantilever wall, and anchored wall. Each of the arrows here, you're seeing are different pressures that would be exerted on the wall. The red is the pressure from the earth or from the soil. The blue arrow represents the pressure of gravity. So in this case, the wall itself. The green represents the reactive forces from underneath, for example, the soil underneath, right? So this is the same for all of them. So let's look at the gravity wall. So the gravity wall holds the earth mainly through its own weight, and it can pivot. In other words, it can shift and topple relatively easily because of the internal leverage of the earth's pressure. All right. So what we're saying is, if you have pressure from this side, it can topple over that way. If you have pressure from underneath, it can topple over towards the back. All right. Then we have the piling wall. Let's see what that says. So the piling wall, this wall is good for high loads. It is good in areas where you have soft soil or tight space. Piling walls are usually made out of steel, vinyl, or wood planks that are driven into the ground. So here, this is the piling wall itself. Note we have pressure coming from this side from the soil. We can have pressure coming from the earth on this side as well. And when you have pressure coming from either side, though, you have the risk of it being broken or fractured, which would now destroy the integrity of your wall. Then we have the cantilever wall. So this type of wall is made from an internal stem of steel reinforced, cast in place concrete or mortared masonry. It can be buttressed at the front or include a counter fort at the back. So this is what we're looking at here, right? It includes a counter fort at the back to make it stronger to hold heavier loads. It will use a lot less material than a gravity wall. So let's look at it again. So this here, you have the wall, and what you have is reinforcement here, okay? So now you have pressure from this side, the vertical pressure from above, which would actually stabilize it a bit more than the others. You have the weight of the wall itself and pressure from underneath. So this will tend to be a stronger example of a retaining wall than these other two. And then we have our anchored wall. This type of wall can include a lot of elements we previously mentioned. However, it is made stronger with additional cables. The anchored walls are great for high loads. So notice this one. This is an example of the cable that they're talking about here. So all of this is underground, right? Because notice you have different levels. You have the back side of the wall that is stopping the movement of the soil. And this is the front side here. So as we said, this type is great for heavy loads. So I just want to continue before we take a short break. So we would look at columns. So a column or a pillar in architecture and structural engineering is a structural element that transmits or transfers the weight of the structure above to the structural elements below. So we were just talking about foundations. So remember, a building has walls as well, and it also has a roof. So columns are usually those vertical structures that would actually transmit the weight of the rest of the building to the foundation. That is why it is very important for you to have a strong foundation, because that foundation is what is going to take the weight of the building. So columns may be designed to resist lateral forces, those as the walls and the roofing, etc. And we have two major categories or two types of columns that we can look at. We have what we call the tied column and we have the spiral column, and all of them are used to reinforce concrete. Here we have some visuals of what that might look like. So this is the tied column. So what you're looking at here is the overhead view of what the plan view of what the column might look like. This is the side view, and this is a three-dimensional view. So you all may have seen some of these before. Before the actual concrete column is built, you will see a metal structure being woven to actually strengthen the column itself, and then it will be encased in concrete. So this is an example of the tied column. This is an example of the spiral column. Okay, so we will take a short break here and return with the rest of the lesson.